Welcome to the week 6 video of Python. So let's start by creating a list L uh, by having values in range 10, let's say. And let's try printing this. So what this line does is it makes a list with range 10, which is 0 to 9. Uh, and this is the list. And we can do something. Instead of printing the list, I'll write a statement. Now let's see what this returns. See, this is giving true. So what this thing is doing is this this is checking whether the number 4 is present in the list L or not. So this in returns a boolean value. It returns true if 4 is there in L, and it returns false if 4 is not there in L. So let's give some number which is not there in this list. Let's give 33. And it is saying false because 33 is not there in the list L. And if I want to print the last element of this list, I can do that by writing length of L minus 1. Because let's see why. See, it is giving 9, right? Let's print the list also. See, the last element in this list is 9. So this length of L minus 1 returns the last element. And we can do the same by writing L of minus 1. So this also gives the same result. See, this is also giving the same thing. This minus this minus basically counts from the last. Okay, so if I give minus 2, it should print second element from last, which is 8. So it's printing 8. So this is how we can access elements of a list from backwards from the last. Okay, now let me have a list of some random elements. So this is a list of some random elements. And as we know that we define lists with these kind of brackets, and we call it square brackets, which are which have sharp corners. These are called square brackets. And let me write something. Let me define y, and let me have the same elements but in different brackets. We call these flower brackets. So let me have those same elements. It's not necessary to have same elements. We can have some random elements. And let me just run it and see whether it gives an error or not. See, it is not giving an error. So this is a correct syntax of Python. But what is this actually doing? Like, what is the difference between this bracket and this bracket? Let's try saying. As we know that we can know type of uh, any type of variable or any collection in Python from print type of something. So let me print type of X, which is giving a list, as we know. And now let me print type of Y. So what does that give? Let's see. See, it is giving set. We studied about set in our school days only. Like set is collection of some elements, and we, as we know, we represent set in this curly brackets, and it's the same thing in Python also. We represent set in curly brackets, and set is also collection of some elements, same like list only. It is also a collection. So now let's try to know some of the features of set. So I'm defining hmm, a list which is same in the range of 20, let's say, and I'm defining a set in a range of 20, and let's print x and y. So both are giving us almost the same thing, except these brackets are different, but all the elements which are inside those brackets are the same, basically 0 to 19. So now I'll try to append x dot append. I'll append some element 30, and ap- okay. Let's append something which is present in the list. I'll append 14 and x dot append 15. Now let's try printing it. See, now it is printing the list with two 14s, one 14 here, one 14 here, and two 15s, because we appended those to this list. Let's try the same by adding uh, the elements to set. So for set, to add any elements to set, we use add instead of append, because append we use for list, and for set we use add. So I want to add 14 in the set, and I want to add 15 in the set. Now let's try printing it. See, it is giving some error. List object has no. Oh, sorry. We should add it in y, right? Yes. See, now uh, this list has more elements than this set. Why? Because we defined both like same only, and we added two elements in both after defining them. But what is happening with list is appending elements to it after defining this list, but set doesn't. And this 14 and 15 are already present inside this list, and these both have duplicate entries. This 14 and 15 is repeating twice in this list. But when we try to add some elements to the set which are already present in the set, it is not taking those elements, because set doesn't have any duplicates. Okay, like set in set repetitions are not allowed, basically. But if we want to append some element which is not there, when we want to add some element which is not there in the set, we can do that. If I want to add 30, I can add it. See, now 30 got added, but we can't add something to a set which is already there in it, right? Now let's try to do something. I want to define a list with a range One with range. How many zeros? One, two, three, four, five, six. 1 million. So I want to define a list with range 1 million, and let's run it first. See, it did it. If I want to print it, I think it can't handle those many elements. So, but it has made this list. So this list basically now contains all the elements from 0 to 9,09,999. Sorry, 9,99,999. So in that range, 0 to that range, it contains all the elements. So, so let me do the same thing, or first let me add another 0 to this and run. See, it did it in no time, right? So the same way, let's define a set with range same as this. How many? Just a second. How many zeros? One, two, three, four, five, six, 7 zeros. Right. One, two, three, four, five, six, seven. Okay. Now let's run this. Okay. Let me increase the number of zeros here. See, it is struggling to do it because the range is very much here. See, it crashed the session. Okay, please wait that you'll get to know what we are doing. Okay, when we have 8 zeros, it did it. And let us have another 0 here. See, it is taking more time than a list to make. See, it, for list, it got crashed after, it got crashed for 9 zeros, and for a set, it got crashed at 8 zeros only. Because basically what we can observe from this is list uh, set is taking way more time than a list to make, basically. So I think it can't handle this. So let's just keep it for 7 zeros. Done and done. Okay. Now let's do something. Let's try to print 1 in L. It's printing true because 1 is present in L, as we can see. So let's uh, try printing -1 in L. See, it is printing false because -1 is not there in the list L because it is not in the range of this. Okay, the same way if I want to search for my name in L, let's say, it's printing false. So the same way we can do the same with -1 in L. Sorry, -1 in S. See, and we can basically do those same things in list and a set. And remember one thing: a list takes less time to make, and it takes more time while searching for an element. To search an element, it takes more time for a list than a set. But when it comes to set, it takes more time while making, but it takes way less time than a list to search for an element in a set. Right. And list maintains an order, and a set doesn't maintain an order. Okay. Uh, Set is just a collection of some elements. Now it's like not an set is not an ordered collection of elements. It's just a collection. But whereas a list is an ordered collection of elements. We can observe that by, let's say, if I want to print x of 3. Okay. Okay, we can do that here. X is a list, and we want to print x of 3. It prints x of 3 as 3. But whereas I want to print y, which is a set, y of 3, it gives an error. Set object is not subscriptable, which in simple terms is saying set has no order. Because it has no order, we can't print the element which is there in the third position, right? So from this we can know that like list maintains order and a set doesn't maintain an order. It's random order. So now, and we can do a simple experiment here by importing a library called sys, import sys. And we can do something. First observe and I'll tell what this does. Okay, now I'll run this. Okay, let us do the same thing. L is list of a range of 10, and S is set of a range of 10. Let's run this and this. See, what this sys.getSize of does is that it returns some value, and this value is how much uh, how much space is given in our computer for this L to get stored. See, I'm printing sys sys.getSize of L, right? So it is showing how much space is taken in our computer by L. And the same way I'm printing the same get size for S also. So this returns how much space is being occupied in our computer by this set S. So we can see that there is so much difference in both of these values. List takes very less space uh, than what you say set, because that is the reason why making a list is easier than like making a list is faster than making a set, because set takes way more space than a list does. And and basically both of these like list and set are both are collections only which contain some elements, But why do we need to use like different two different things for storing? Like both are used for storing some elements. So why do we have different types of collections? Because both have different use cases. Like for some use cases, we need to handle the data with lists, and in some use case, we may need set to handle that. So it all depends on what we are working with and what we need in our work. So now till now we saw s- some collections like this. Uh, See, these are some random values. Okay. Now we have some a collection with square brackets, and we have a collection with flower brackets. So which bracket is left? It is round bracket, right? So I'll define some uh, values with round brackets. So let's try to print type of each of these collections. Print type of L. So print type of S, and print type of T. So let's run this. See, first, as we know, this is a list, and today we came to know that this is a set. And there is another thing called a tuple. So, what is this tuple? We define a tuple in round brackets, and this is also a collection basically. It has some elements. It can have any type of elements. Can have a string also. Even then, it is a tuple only. Okay. Now, see, these all three of these look very similar, except these type of brackets they use. But what uh, is this like? How is this tuple different from a list? So let's see that. So to know the differences between each of these, let's try doing something. Let's take out this. And now let's print L of 4, print S of the 4, and print T of 4. Okay, now let's run this. As we know that oh sorry, this doesn't have 4L. Okay. As we know that we earlier also we got the same error, which is we can't access the set by okay, we can't access an element at a particular place in a set because it doesn't maintain an order. So let's comment out this line and let's rerun. See, we can access an element at a particular order in a list and in a tuple also. So, which tells us tuple maintains an order. So, tuple maintains an order and list also maintains an order, but set doesn't. Right. So, this is a major difference we can see in all three of these. But let's try doing something. L dot append 23, and s dot add. Uh, as we know that for set we use add instead of append. Add 34. Okay. See, 34 is already here, so it doesn't add it. So let's add 36. So the same way, let's try adding, let's say append. We don't know what we need to do to add something to a tuple. So let's try with append something. I'll write. See, it's giving an error. It is saying tuple object has no attribute append, and we cannot add or remove elements from a tuple. Okay. So tuple is unchangeable. We can't change, add or remove elements from a tuple. So then, why is it unchangeable, and uh, what is the difference between a tuple and a list? So let's see that. Basically, a tuple is used where there is no need to change the elements which are there in it, right? So list is used where we perform some operations like removing some elements and adding some elements. Like list is basically used in places where the elements inside the list change, like either new elements come or existing elements will get removed. In those places we use list, and we use tuple in places where we are sure that the elements inside it won't change. For example, let's define a tuple which is alphabets, let's say. So here I defined a tuple with all the alphabets from A to Z, and we are sure that no element will be removed or added to this alphabets, right? So in the place where we know that the elements inside some collection won't change, there we use a tuple. So let's do a simple experiment here. Let's define a string called R with some random words. Let's say and some special characters also. And see, this is some random string. So what now I want to do is I want to extract those characters from this string which are present in this tuple, right? Which basically I want to get rid of all the special characters and special characters or numbers, and get only those uh, characters which are there in alphabets. So I basically want to get all the alphabets from R. So for that I can define a for loop which says for, and here I can define a string which captures uh, the found elements. So now let's print s. Okay, we need to define these as strings. So let me do that. So now let's run this. So it is printing only the alphabets, right? as we know that this in is used to check whether it is present in that or not, if this p is present in alpha or not. So, like when we are sure of a list that we are handling and we are sure that it never changes, then we use a tuple. So, this is about tuples and sets and lists and differences and similarities between them. And you can explore the methods which are there in for lists, tuples, and sets, and you can explore and practice them. And thank you.